will be intuitive for you. And just for information, all the participants will stay muted during the presentation. We encourage any participant to post any questions via the control panel. If you want to refer to a slide number, please do so in your question. And after each section of the presentation or at the end, we will then come back on the questions and ask them to Emma. The webinar polls also are a tool to get your inputs. Webinar polls are basically short questions, whether you use single answer or multiple answers it depends on the question. And we will actually, I think, start right away with one question. And the first question is, from which region are you from? It's a simple one, and it's make sure that you understand how the poll are working. So you should see that appearing in your on your screen. So from which region are you from? Europe, USA, Asia Pacific, or others? And we see on our screen how many have voted: 74%, 75%, and usually we stop at around 85%, and we yeah, 91. So now we can close the poll and show it. So we see now the poll. It should appear on the slide, and we have 77% of the people having voted for Europe, 19% from US, and 4% very early in the morning or during the night from Asia Pacific. So then let me continue. You can. So now that we have done the poll, I'll give you a little introduction on the VRA support actions. So VRA stands for Vehicle and Road Automation, and it's a support action 100% funded by the European Union to create a collaboration network for experts and stakeholders working on deployment of automated vehicles and its related infrastructure. It's an FP7 project, and the objectives are based on two main pillars. The first pillar is the work that we do with the Mobility Forum Automation Working Group, where we create this expert network at European level and foster cooperation. Mobility Forum then, and then the second pillar is the EU, US, Japan ITS collaboration, mainly through the EU, US, Japan trilateral working group on road automation. The chair of this working group are the European Commission on one side, USDOT on the other side, and then MLIT from Japan. How do we feed these different pillars at European and international level? We create discussion groups on the deployment needs, and these the current deployment needs that have been identified are, for example, the deployment path, regulatory issue, testing and evaluation, connectivity, evaluation of benefits, digital of infrastructure, human factors, and decision and control. These are discussion groups that are mandated to create a report, and in this and these reports are feeding the discussions within the Mobility Forum as well as the EU, US, Japan trilateral working group. Then, in order to be as transparent as possible, we promote all the research and on known vehicle and road automation projects through a wiki. So the tools that we have to give you more information is a website about the VRA activities. We also use a Twitter account to have as much information as possible. Everything that we find on vehicle automation, we just put it there. We have the VRA wiki that I just mentioned, and then the webinar series that we are using today. The beneficiaries and associated partners of the project are listed here. We are welcoming associated partners through a letter of intent, and the primary group is the European partners, but of course any international partner is very, very welcome to be associated to that VRA network. I list here the different events that we have covered over the last few months, and then also the next ones. One very important one is the Michelin Challenge Bibendum in Chengdu, China, where we will have a special roundtable on the ADAS and automation. If you have the chance to be at that Challenge Bibendum, please notify me so that I can invite you to these, or do everything to invite you at this roundtable. Also, the workshop, the international workshop on connected and automated driving that will take place in Tokyo on the 17th, 18th. The 19th of November, we will have the next trilateral EU-US Japan task force meeting, or working group meeting. And then I'll let you read the next ones. We will have a City Mobile VRA workshop with the city authorities, and next we will continue with the TRB meeting in 2015. So this concludes my my introduction. So there is actually just noted that we have a second poll before we start with Emma, and the second poll is, which sector are you representing? Just to make sure that we have an overview of who's represented in the audience, and we have about 70 participants, and I see that see this fluctuating. About half of the people are from research organization, 25% are from automotive manufacturers, automotive industry, public authority 17%. That's quite good, and then the rest so a quarter from the automotive industry, and a half from the research organization, and 16% from the public authorities. Very good. So we really appreciate that you take the time to be in this webinar. And now I'm going to give the hand to Emma Johansson from VOLVO Group. She's going to present the adaptive activities. Very welcome, Emma.
Thank you. Can you hear me?
Yes.
Yes. Okay. So thanks for inviting me to do this talk. I will present human factors work that we are currently doing in the European project called Adaptive. And I'm from VOLVO Group, which is the VOLVO part, which are working on heavy vehicles and machineries, buses, and so on. I'm at the Advanced Technology and Research part of AB VOLVO. We have roughly 500 employees, so I just want to mention that. I will speak about, this is the outline of my presentation. I will give a short overview of Adaptive as a project. I will talk a little bit on collaborative automation, which we are focusing on when it comes to the human factors work. There are many human factors challenges, and I will just briefly mention this. I will show the work process we have ahead of us, and give some examples of work we're doing on design guidelines in the area of human factors, and some outlook where we're going, because Adaptive started this year. It started January, and it's ending in June 2017. The coordinator is Aria Etemad in Germany at the Volkswagen Group. We have 30 partners on board from a quite large range of European countries, and we have a division between OEMs, suppliers, research institutes, and smaller companies. The general objective in adaptive as a whole is to create a widespread application of automated driving to improve safety, efficiency and comfort. And I should also say that adaptive is of course funded by European Commission and the partners involved. I forgot that. The aim in adaptive is to look at automation in different environments and different automation levels. We are looking at enhanced perception performance, for example VGX, so on, and also cameras, lasers, etc. I'm involved in the driver-vehicle interaction part, as I mentioned, and we also have a lot of partners working on evaluation methodologies to assess the actual impact of automated driving. And of course we are heavily involved in the legal framework. See if I can see the whole part of my slide. It's a little bit difficult, just a second. So as I said, we are focusing on different environments. We will develop a range of demonstrator vehicles in adaptive, and we will look into a wide range of different use cases, and these are just the top headline. So we will look at parking and low speed maneuvers and develop vehicles there. We will look at test and develop applications for medium speed maneuvers in complex scenarios, so for example in urban areas. And we will test and develop applications for cars and trucks on highways, and this is where VOLVO is involved in, but also others, of course. Let's see. Okay, seems like something is stuck. Okay, this is then an overview. So you've seen many pictures like this, and this is from adaptive, just to give you an idea of the structure of the different sub-projects. So it's a big IP with many partners, where, for example, legal issues are presented in SP2. So it's a continuation on the previous response projects, and this is Daimler leading that. I'm from VOLVO, and we lead the human vehicle integration part in sub-project 3. Then we have the development of the vehicle and functionalities in sub-project 4, 5 and 6. And we have a very important sub-project also in the evaluation framework, where IKA is leading the work. But I will focus my presentation on sub-project 3. So you've seen the different documents on levels of automation, so I thought I'd just put in what we use currently in adaptive. We are focusing on the SIE levels of automations, which are relating to the previous or the ongoing ones, the BATS, the NHTSA and so on. So in adaptive, the applications we develop are focusing on level 2, 3 and 4 according to the SIE levels. So for example, you have parking with remote control, you have on different levels, and you also have automation on higher level 4. So I will not go into detail on the different definitions, but as you see here, the level 2, 3 and 4 all mean some sort of collaboration with the driver. In sub-project 3, we work on, we decided to call it human vehicle integration, and we added collaborative automation. We wanted to continue the work that we've done in previous project, H-mode, Habit, Interactive and so on. And by collaborative automation we mean that this implies the idea that the automation and the driver has complementary skills. And we should see if we can use those complementary skills together to achieve a common goal. And of course this is not easy, but this is the backbone. And the basis here is continuous communication in some way and continuous interaction between two partners, so driver and automation, with regards to both the driver and automation's intentions, abilities, actions and limitation. And I'm sure many of you have seen this picture, and this is part what's developed in Habit. The challenge is that so far there is no fail-proof software, and to replace the human being behind the wheel with a machine which is designed by another human only works if the task environment is very static, predictable and a priori controllable. That's at least the notion that we represent in SP3. So the tricky thing is, of course, so what do we do with the driver and how do we design this collaborative automation? So in many areas there are different options on how to treat the driver. You could have the option 1, which is the driver monitors the automated system. But the problem is there, of course, that drivers are humans, and as we've seen in other domains, they make quite poor monitors. We are very good at being active and so on, but we don't like staring at screens for several minutes, hours. That can create vigilance problems, boredom, so sleepiness, and so on. And ironically, if you have a really good system, creates high reliability. If you have a high reliability in the system, it creates over-reliance, so you get that problem if your system is actually working good. The second option is quite similar. There you have the driver as a backup to the automation, and you have the problem that controllers actually need manual and cognitive skills to function well. And this is part of the ironies of automation that Liz and Bainbridge presented a long time ago, and it's also relevant here, I think. So you have skill degradation and out of the loop. So here we would post a question in between to have a bit of an interaction. So the question I suggested was to have you answer which are the best alternative designs to avoid a passive driver.
So we open the poll, Emma. I'm not sure you can see it, but everyone else can see it. So
okay.
It's open for everyone to answer. I see people starting to answer now. And so, which are the best alternative designs to avoid a passive driver? And then we have 4 possible, but you can select more than one. Driver should be instructed to drive now and then. Driver needs to supervise constantly. Driver always involved in navigation strategic level, and none, it's okay for the driver to be passive. So we see that about 56% of the people have answered. Let's see. Okay, we will close in a few seconds. 5 seconds. Yeah. 3, 2, 1. Then we can close. So we have 79% of people that voted, and the answer driver should be instructed to drive now and then, 44%. Then the second one is driver always involved in navigation at the strategic level, 36%. And driver needs to supervise constantly, 20%. And then another 20% said none of these is needed. The driver can be passive or may be passive. So interesting. I'll leave you to continue, Emma.
Okay, thanks. And of course, if you have, sorry, say.
Of course, if you would like to comment, you're welcome.
Yes, and yes, and if you have, of course, these are some options, but there are also other more detailed. And of course, please contact me for any ideas you have. The option 3 that we are working accordance in adaptive in SP3 is to have the human and automation to both participate in the control through some sort of partnership. And of course, we are in the start of the project, the year 1, and we will build up on previous knowledge in other projects, but this is something that we'll work on for the following years, because it's very important to not just state this, you have to design it, and how do we find the correct partnership is of course the first question, and the authority issue is of course extremely important, regardless of how you find this collaboration. And how do you automate part of the tasks in order so that the more difficult tasks don't get even harder for the driver? And I add another question here. because what is very interesting is what people find, how much knowledge can be transferred from other domains to vehicle automation when it comes to those issues with the human factors issues in general, but also shared control and so on.
So David just opened the next question then. How much knowledge can be transferred from other domains to vehicle automation? For a lot, and then 0, nothing, or very little. And after that, I guess you will ask to everyone which domains, or how do you?
Yes, it would be. We didn't have that in here, but so I left it open. But
So
that would have made sense.
Yeah, we can leave to anyone to post questions, and I already see a few of them posting comments on this. So yes, we can close really the poll, and we have well quite an optimistic set of answers. So 33, a third of the people said a lot of the knowledge can be transferred from other domains, and then going down 28%, 25%, and then 10%, and then nothing for 5% or very little. So yeah, it seems that it's optimistic future for that. And some comments lead to defense, knowledge from the defense industry and aerospace industry should be taken into account. I'll let you comment, Emma.
Yeah, thanks. So in previous projects and also now, because we inherited a lot, of course, we are looking into other domains, but it's very important to that's my own opinion, that it's really important to map the differences when it comes to timing to react, for example, and what kind of information you have available, what kind of actors are do you have in this interplay. For example, in aviation, you often have a ground staff supporting you and so on. But this is a very interesting topic, so I'm happy for any interaction on this after this presentation. I'll just show the planned work process that we have in Adaptive on SP3. So as I mentioned, we have numerous projects where SP3 partners have been involved. I'm just mentioning a few here. We have, of course, the PREVENT projects that took place a while ago. We have, which was on active safety. We have SARTRE focusing on platooning. We have Interactive and Habit looking at automation and active safety in different levels of degrees of automation. We have D3 COS looking at different domains and interplay between the technology and human. Then we of course have all the studies supported and funded by NHTSA and other organizations in the US, as well as independent papers that we of course look at, and also design guidelines, human factors, general human factors research, ESOP, ISO, etc. So this is kind of like the backbone. We started off by doing use cases this spring, as I guess you do in most projects where you want to develop something. So this part is done and was led by Ford. This gave us an overview of a brief overview of each functionality, how we saw the interplay from a starting point, and we did this together with the demonstrator owners and the engineers in a cross-competence teams. We are now looking into the state of art of human factors research, and a lot of the stuff is from Habit, for example, and Interactive. You could expect that more should have been done, but there are a lot of studies done on ACC, for example, and how ACC works together with a human being and how people react, but there's fairly little done on higher levels of automation. So it means we have a huge, there's a huge demand, or it should be a huge demand for human factors research when it comes to higher level of automation. That's kind of surprising, and we are kind of part of that. So Based on this literature review and the state of art, we have also posted a research question, and that's something that's ongoing now. So that's something that I also could urge people to bring up, which questions you find are interesting. We will do experiments in different environments. The core studies will be done in research laboratories, simulators, and so on, but we will try to make them in a more real environment if it's possible, if we can get hold of the vehicles that we develop in the project, especially for parking assistance. Of course, it's easier. We are working on the design guidelines, which I will mention a few today, and this is an iterative process, so actually the error should continue around. So we have done the first draft of those design guidelines, and we will continue filling them with more information as we see the results from our experiments. This is just a quick overview of the use case, and I guess I should have enlarged it a little bit, but it's just we do a lot of those for each vehicle and function that is being developed in the project. This is just part of the use case. It also consists of a narrative and other descriptions. I just want to stress that in adaptive, we don't only look at intended and expected situations. However, this is of course the starting point. We also looked at unintended and unexpected situations. So and the transitions, of course, in between. This is the first sketch, how we see the transitions between what the vehicle automation intends, what the driver does, and so on. And as we go along in the project, we will fill this with more information. And we do main flow, you could say, is the happy state, what you intend, and then you go with alternative flows and you continue. And of course, the tricky thing is to know where to stop, how much you should take into account when you do your use cases. They can be extreme. You can make it extremely complex. Then I move on to the functional requirements and the design guidelines that we aim to produce in this project. And a lot of the input we have here is from Habit and Interactive, because we did similar work in Interactive, which that project ended last year in November, I think. And we did this work, and now we are focusing on a little bit higher levels of automation, but still a lot of those guidelines that we produce will be useful here. And much of the work we did in Interactive also linked back to Habit. The categorization you see here is something that we are currently trying out. This is from D3 COS, and with DLR leading this work. So we start from left here on agent state problems, which could be failure limits, environmental conditions, could be drowsiness, fatigue, workload, knowledge experience, etc. I haven't mentioned all here. Then it could be awareness problem, perception, comprehension, mode awareness, attention, beliefs. Then the third one is intention, decision problems, goal settings, task allocation, responsibility. I put unintended use and then I put misuse in brackets, because that's an area in itself, how to define that, what is actually misuse and so on. And then more hands-on interaction problems. So for example, how you present information, how you communicate this via what modality, when you present feedback and when don't you. The arbitration between the driver and automation, for example, look at compatibility between what the driver wants to do and what the system wants to do. Mental models, I know it's a tricky concept to define and to evaluate, but we put that in here. And also the transitions between, for example, different levels of automation. And last but not least, the action problems, so physical constraints, motoric constraints. Can you respond in time? Where do you sit? How do you sit? Where do you look? Lack of skills, as I mentioned before, the skilled drivers, for example, and also a very important, more general concept, controllability. So these are the categories we will start producing our guidelines by, or have started already. So I will mention some design guidelines, and since we've just started this work, this is coming from existing literature, and the examples I have today, I thought I would focus on drive state, just to pick one category because there are so many, and this is work based on in habit, but and also in of course habit based on other sources. So so this is an agent state related problem on driver state, and as it say here, this is kind of how we will phrase it. So an inattentive driver could be due to drowsiness, or that he or she is engaged in a non-driving related task. That driver will no longer, or will even be unable, to react to a system-initiated transition. And this might sound kind of basic, but it's something to really take into account throughout the design and development. So basically the system needs to know that the driver has this limitation. And in order to assess this, whether the driver will be able to react appropriately to a system-initiated transition, you need to have some sort of driver state monitoring component to in the vehicle. So, and I'm not saying how this could be, but because it could differ based on the function and the type of transition and so on. But for example, it could be head or eye tracking, but it doesn't have to be. It could be that the driver actually sits in his seat or is facing forward. Then this one is also related to driver state. So driver state assessment should be able to both detect long-term inattention, such as engagement with a non-driving related task, short-term, as well as long-term inattention, such as drowsiness or driving if you're drunk or other substances, or just had a heart attack and is not attentive. And here is an example of driver monitoring by a camera, but of course there might be other ways to detect this. Another design guideline, an example, is on the driver state and the transition. So if you have a driver in an impaired state, it's recommended to have a stepwise escalation scheme. So not just shutting the system off without confirmation that the driver is actually able to take control. So this is also from habit. So let's say you have a drowsiness indication, you present a warning and a takeover request, but if that isn't happening, you need to design for this. And in habit it was, and also in interactive, design with a so-called minimal risk maneuver, which could be, for example, that you slow down the vehicle or you drive to the side, or whatever the system is able to do. I move on with another example. So this is also agent state related problem and related to driver state and transition. So in a time critical situation, the driver must be brought back to the loop quicker compared to a non-critical situation. So that's not so strange, but it also could mean that the higher the automation level is, the more time you should give the driver to bring him or her back in the loop. So for example, you might have a system acting on level 4, but you need to bring it down to partial automation, for example. So you need to adapt the escalation scheme based on this. So both criticality of the situation and what is the current automation mode. I think this might be the last example. This is about unintended use. So there are a lot of videos on YouTube on misuse or unintended use and abuse. I don't know how to define it. Since I'm focusing on usability in my daily work, I think it's important that we define what is unintended use and what is intended use, and start with that and actually try to really create a design that makes the intended use clear to the driver and will avoid obvious misuse. I mean, you cannot if a person jumps to the other side, to the passenger seat, or really try to fool the system, that's one thing. But I think there are a lot of gray zones where we could be better at designing very clearly what the system is supposed to support you with. So let's say a driver could probably use the system in an unintended way, for example, to doze off or have a nap. And if this is not the intention of the designer, or you could design a system that the highly automated mode should be disabled. And but of course then you go back to the transition, so you have to present the transitions in a safe way, and you should probably still prevent the driver from safety critical situations. But this is also important to build in. So by those examples, focusing on driver state, I also want to emphasize that when you work with human factors issues, it doesn't only have to do with the output layer, modality, and so on, which is very important, but it's not the only thing. You need to look at both the automation and the driver state. So the driver needs to be aware of the system state somehow, and the system needs to be aware of the driver state. Then you also need to consider the different intent and actions that those two actors have, and create this good coexistence, basically, that this is clear. And in order to do that, you cannot just focus on the output layer. You need to, as a human factors person, you need to be involved in the application platform and even in the perception platform layer, and to create, to support with human factors knowledge to create this driver. And I should be, it's wrong here, it should be the driver state down here and vehicle state. And to have this joint driving action strategy, the logic, this is extremely important when designing automation. The outlook in adaptive for the human factors work in SP3 is that we are currently creating a first version of those guidelines, and it's based on the current state of art, which I already mentioned, with the main focus on habit, interactive, and age mode. We are also currently collecting research questions, and we intend to run experiments. There will be 16 experiments between the now in the fall and beginning of 2016, and the intent is, of course, to provide updates to those guidelines, which then will be the input to how we design the vehicles in the projects, but also provide this beyond adaptive, so not just for the functions in adaptive. And I think I have a question here. Yes, I would like to see which research questions should be the most important ones for us to focus on. And I couldn't give you the whole Excel list filled, but you could email me afterwards.
So we have opened the poll, Emma. So the different possibilities are driver state, secondary task, engagement, fatigue, boredom. That's the first research question. How drivers handle system limits and failure. Third one, mode awareness, confusion, levels of automation on-off. And fourth one, system and driver action compatibility. And then finally, others. And hopefully, so people that say others, they also, we will have to see how they can write it down in the questions. Do you want to comment while the people are answering?
Yes, I know from experience when I worked in Interactive that we collected research questions from both trying to see the gaps in the literature existing and other projects running parallel. We asked, of course, our colleagues in the project, engineers, human factors people, everyone and you can fill quite a few whiteboards with questions. So there's a lot of, it's a big need for this research. I'm a bit biased, but
of course we are all biased. Okay, 82% of people voted, so out of the 77%. So to summarize, 62% have opted for the second option, how drivers handle system limits and failure. And then more or less equal, the other ones with 43, 39, and 41%. Driver state, secondary task, engagement, fatigue, boredom, mode awareness, confusion, levels of automation, auto and on and off, and then systems and driver action compatibility. So similar level of questions. And then only 7% have said others. So if people want to note if they have other questions. Another question might be the desired LOA. So I'm sorry about my bad LOA, level of action, or
level of automation.
Of automation.
Yes. Yes. Okay. Interesting. Okay, but I don't know if I put my email somewhere, but I would be really happy for any interaction on this, since we are in the stage where we will decide and prioritize. We have our 16 studies that we have budgeted for, but
okay.
Yeah. Mm-hmm.
We'll hand over back to you.
Yes. Okay. So this is one way of categorize the different research questions there might be, or there are, we've found. I highlighted shared control since we talked, this is the heading of the SP3 collaborative automation. How can driver and automation act in parallel? And can they act together but on different levels of control? For example, that the driver is in on the navigation more strategic and the vehicle is supporting more on a lower level, or are there other ways where this can take place in parallel? Or will this create just new problems? Driver in the loop is situation and mode awareness. I know situation awareness is debatable concept, but still we added it here. Then you have the questions that was rated quite high, right? 62%, so that's good. We have it in here. So how can drivers manage limits and failures? Can you actually have the driver as a backup when the system have limitation, or is this just not possible? The transitions, so a lot of those categories, by the way, are overlapping a lot. So how do you have those transitions? So this I would put here is a lot of the arbitration between the system and the driver, and how do you design this arbitration in different scenarios when it's system or driver initiated, or intended and unintended transitions. Also related to controllability, of course. Then you have what I gave some example from, driver attention and state, and there you have the secondary task engagement, of course, and also drowsiness. And last but not least is the actual interface design. So how do you, what modality and what kind of timing, how do you present the information, where do you present it, do you present it in a head-up display, can you actually present levels of automation in your cluster, or is that distracting in itself, so on. Yeah, there are lots of questions. This is just the tip of the iceberg, or the categories. And this is my final slide, so I don't know if I kept the time or not. I hope so. So I just wanted to present my colleagues in SP3, because this is of course a joint work, and I'm presenting a lot of what has been done by those colleagues, both in adaptive as well as in previous projects. So we have people who have experience from Have-it Interactive, the national German projects, H-Mode and Active, for example, Sartre, D3 Cost City Mobile, which is ongoing. And our work very much starts from this experience and this knowledge. And at the VOLVO group, we have me and my colleague Pontus mainly now, and at Ford it's Stefan Wolte, Martin Brockman. VOLVO Cars, we have Mikael Ljung-Aus, Trent Victor, Malin Farmason. At DLR, it's Johan Kelch and Mark Desenius. And we have University of Leeds, Natasha Merat, Georgios Kontoritis, and Tylo. And this is the abbreviation. I'm not so good at but the research institute in Würzburg, WIVW, and there is Nadja Schömig and Katarina Wiedemann. So I want to give credit to them, and I want to thank you for listening, and I want to emphasize, please post questions to me by emailing me or here, or I don't know. Yes, thank you.
Very good, Emma. I think we do have a lot of questions for you, and we have 15 minutes to go through them. First, I wanted to mention that defense and aviation were referred as in a few of the comments as the main domains from which we should get more knowledge. Is there something done in this respect in adaptive?
We have looked into the military standards, and for example, I know from interactive, which we are feeding into adaptive, and of course basic human factors guidelines. It's true, according to me, it's true regardless of area. You have there's a human being controlling machinery or a vehicle and so on. So we have that, but when it comes to higher level of automation, I haven't found that much. I found an interesting document which is from military domain from US on how to view levels of automation, whether that's a good or bad concept. So that's something I looked at a little bit. But yeah.
Okay, so I guess if anyone in the audience can give you tips, it will be welcome.
Yes, absolutely. And also within the automation domain, because at least when we've looked at sources to guide us, there is not that much human factors work on higher levels of automation, we've found. And we've mainly tried to focus on experimental research where there's actual studies done and not position papers or so on, but really, yeah, what we aim in adaptive basically, really studies.
We do actually have some conflicting or comments saying that car drivers are not the same as pilots. They do not get as much training, and there are many more cars on the road than planes in the air, and so much little time to react to some of the situations. So yes, well, we can get some knowledge, but not always. I have another comment on the fact that let's say Google has stated that level 4 automation is something that they have looked at, but they actually prefer to go from level 3 directly to level 5 automation.
Yes.
Can you comment on that?
On their business case? No.
No, on your view.
No, I think the way I've seen it, but this is based on what I read and probably the same sources many have. There are different business cases, and I think most OEMs today are doing it gradually, because we are we know what we have in our products, and we are very cautious about the safety of our products, and maybe we have different use cases and market plans.
Okay. Another question: when you presented the functional requirement design guidelines, is how much time do we expect the drivers at the end to take over from the drowsiness indication to the to later? So what is the time scale that you're looking at?
Yeah, I think a lot of the radars and sensor, that's depending on who you talk to, I guess, but for many engineers 5 seconds is a long time to predict what's going to happen. But I think if you read a really good book, or if you're dozing off, and if you have designed your driver environment that you can shift the car seat, for example, I think it's more than 5 seconds. So it really depends, and I don't think you can. I think it's difficult to put a figure, but we will look into the interplay between the driver's secondary task and the possibility to take over. But I think it's difficult to say, okay, it's if you can be allowed to make a phone call, or you can be engaged in listening to a book, and then you will be able to take over in 5 seconds. But you should design an escalation scheme for this. I think it's more like that than to put a figure. But that's my personal opinion.
Okay. Just by referring to another project that you mentioned in Sartre, Sartre mentioned even minutes to take over.
Yes.
Is something that you're...
There you have a platoon, though, that you have a vehicle in front which is obstructing your view ahead. You have maybe you don't have any knowledge of where you are in the road environment. You are kind of blocked, so I think that's a bit different than the use cases we look at in adaptive.
Okay, very good. One question was more practical. How are you actually going to present the guidelines at the end? Is there documents or that?
Yes, we will produce a deliverable like in all EU projects. The processor of adaptive is interactive, and those guidelines are quite open. It's not fully open, but it's open to all partners or people who've been involved in Framework 7 in the EU. And we also have a smaller public version of it. And we haven't discussed that internally, but my view is that we should have it as open as possible, because I think it's too important. And I know there's also US initiatives in the Connected Vehicle Program which are working on similar things, so I hope we can have a close connection.
Okay, there was the questions are keep coming, and I'm trying to catch up at least with the ones that have been posed during during your presentation. One comment was saying, why don't we just try, instead of avoiding unintended use or misuse, why don't we try to detect misuse and then respond to it on the way? I mean,
but I think that's a little bit maybe what I mean. So first, of course, you have to define what's intended use and misuse. But for example, and I don't know if you can always foresee or detect it, because drivers or people can be very creative, which is a benefit, of course, normally in the world, but maybe not during driving in this question. But that's what I mean. So you need to design to be able to tell the driver, no, now you are using the system not according to how it's intended, like that the support times out if you are drowsy, for example. Then you detect people are trying to take a nap. Okay, that's not really what we cannot let the driver do that. So that's, in my head, that's about detecting misuse.
Okay. I have a few other questions. I'm trying to decode. Here, the best way to preserve awareness while leaving drivers do other. What is the best way of to preserve awareness while leaving drivers do other things meanwhile? I don't know if you have an answer actually.
To let the drivers do other things, to be vigilant, is that, I'm not sure if that's okay, because the people are getting bored, so you need to let the drivers do something, is that?
Yeah.
Okay. How can you preserve awareness at the same time? I mean,
say the question again.
How can you, what is the best way to preserve awareness while leaving the driver do other things in the car meanwhile?
Yeah, that's a good question. I'd say I don't have a clear answer to that.
Yeah. I guess it's
that's part of the
answers.
research questions in the project. And if someone has ideas and ways to phrase it, or that's just send it.
Then,
one idea would be to be active on a higher level, so you are present at in some way, but you don't do the operating part of driving, which is of course also what it says in the SAE, but maybe you should be doing some of the navigation or maneuver strategic parts of driving.
Okay. Another question, are there any good examples of human automation cooperation in operating environments, in other, I guess it's also related to other domains?
Yes, I think so. I think in factories, for example, I think that's actually, but that's not my domain then, of course, but I think at least people are looking into how you can have cooperative automation, for example, with the big robots, because you have the same problem there that you don't, if a robot gets standstill, you don't know how to jump into the process. Where is it and as an alternative to sit and just look at a monitor? So I think there are, but again, good examples is welcomed.
Yeah. There is another question, and I think you have answered it, but you can perhaps take it again. Do you think it is possible to transit between different levels of automation, or should it always be only on or off?
Yes, good. That's a good question. That's one of the studies we want to do, I think.
I had the impression you answered.
Yeah. Okay, yeah, in Habit we had 3 or 4 levels of automation depending on the vehicle, I think. So we had the full lateral and longitudinal support, and we had ACC in between, and then we had driver assisted, where we had the basic driver assistance systems, warning and intervening in critical situations. So I think that's the answer, but I know, for example, if you have the Google car, there's no steering wheel or pedals at all, so that's really a full automation and no transitions at all.
Yeah, an interesting question. Do you see a risk, or did you see a risk with motion sickness related to automation? So motion sickness will cause even greater problem with driver fatigue, and when driver lose control, motion sickness will occur.
I haven't thought of that personally, so that's a really good question, and I can bring it into the group in SP3. I don't know that anyone has the intention to study that specifically at the moment, but that's interesting. I only studied motion sickness in our lab environments.
Another question before finalizing. Design guidelines were mentioned. Do you plan other outcomes such as methods, frameworks for developing automated driving interfaces?
We will do the guidelines. We will not design the specific interaction for each vehicle. We will not sit and do the graphical user interface, for example, for each OEM, but we will provide guidelines for this, and we will make examples of how it can look like. In Interactive, for example, and in Habit, we did like prototypical designs and suggested common design elements that everyone could use. And then, of course, when it comes to methods and tools, we don't. The only human factors work is not only. It's not only done in SP3, but as I mentioned, we have also SP7, which IKA are leading, and they will focus on a methodology and have a common design, a methodology, valuation methodology. So, and both for technical and user-involved testing. So I recommend everyone also to pay interest to that. And in SP3 we will do iterative testing. So the setup could differ a little bit depending on the research question we focus on. So we might not have one set of study design for all 16 studies, but we've already talked about how we can make commonalities, for example, when defining dependent meshes and how to design scenarios and so on.
Okay. I actually have a very last question, and perhaps you can be short. How much is this linked also to the response tree code of practice developed in 2008?
Yes, we have that as one of the references. That's why I put prevent because it's not only response part of prevent, but also and response continued into interactive, and it's part also in adaptive. So of course there's a link to the code of practice for active safety.
Very good. So we encourage any participants to send you information or suggestions or questions.
Yes.
And with this, we really thank you very much for this very good presentation and discussion. And thank you. Thank the people from Interactive Adaptive, and then also thank all the audience. And we wish you a very good weekend. Thank you.
You too.
Bye.
Bye.